Okay, this video we're going to talk about exponential uh, growth and exponential decay, continuous exponential if continuous exponential growth or continuous exponential decay. And this, when the we have decay r is less than 0 and growth r greater than 0. Okay, let's give you an example. If you have like some bacteria, this bacteria grows at a continuous exponential rate. For example, at the beginning we have 10 bacteria, and then after time, at the beginning this one t is equal to 0. At the time of t0 we have 10 bacteria, and at the time t we have for example 85 bacteria, or sometimes people write it y0 ERT. This is the same. This is y0 is principal initial amount, and that is p the final amount. The initial amount is 10. We have 10 bacteria, and after t, that we are gonna say that after like 12 days, t 12 days, it's gonna grow to 85 bacteria. Let's solve this to see. First of all, we have to find the general formula. General formula means that P is equal to, like see here, let's put the number here. At the time t, like after 12 days, 85 bacteria we have, and then at the time 0 is 10, then e to the power rt. Okay, r is the relative rate of growth or decay. This is growth, because from 10 bacteria it's going to get to 85 bacteria. So what we do, we know that t is 12, so 12t in this formula. We put it in this formula. Now we are going to find a general formula for that. General formula, find general formula. See, to find it, to find the r, I'm sorry, t, t is 12 and 12r. We are going to find r. If we find r, then we can find the general formula. So what we do, so 85 divided by 10 is equal to e to the power of 12r. And that is going to be 8.5 is equal e to 12r. See, if we get natural log of both sides, in order to find r, what we do is say ln 8.5 is equal to ln E12R. See here, actually ln 8.5 is equal to 12R, because this is has a E. This actually has a base of E. You know, means this one. What it means? Means what we raise this one to a power of something is going to be this, so it's going to be 12R. So that's why it like this. So R is equal to ln 8.5 divided by 12. Okay, and then what we do is we find R. Now we are going to write the general formula. So the general formula is going to be general formula is going to be, or you can, P is equal to 10, the initial amount, 10 bacteria we had, and then E times to the power of ln 8.5 divided by 12. And then this is R, and T, we write the T. So this is the general formula. This is the general formula. Now you have the general formula, but it means that at any time you can find how many bacteria in final amount, and so for example, you want to find after 20 days. After 20 days, T is equal to 20 days. How many P's? How many the final amount? How many bacteria we are going to have? You know, for sure. As the time passes, the more bacteria are going to grow. So we put this here, P is equal to 10E ln 8.5 divided by 12, and the whole thing multiplied by 20. So, you know, you can find it. What you do in the calculator, you ten times e to the power of, see, ln, if we parentheses, ln, this one, 8.5, and then this one divided by 12, and then times 20. Okay, let me. Three 354.02, and you know you got the they ask you to round it to the whole number. Whole number is going to be 354 bacteria at the end of the 20 days. So this is bacteria. So what happened, you know, what we did here, that we have the initial amount of bacteria, it's 10, and then the final amount, if it's T is 20 days. See, the first time, but T is we said after 12 days we found the R, and then after we find out, we find the general formula. We find the general formula for this. Okay, this is R. The whole thing here is R. R is equal to R. So after 20 days, the number of bacteria is going to be 354, and so you see that, like at the time of 0, for example, here we want to find the time at the time of 0. What is that? E to the power ln 8.5 divided by 12 times 0. This is 0, and then P is equal 10 times E to the power of 0 is equal, this is 1. Any number to the power of 0 is going to be 1. So it's going to be 10 as we get the initial amount. So this was the exponential growth. Now we have, like in radioactivity, we say like half a life, 1/2 a life of a substance. Or maybe I give you this an example here, like we had this time you're going to use y, you know, in some places they use y. Say y is it going to be like suppose y0 is going to be equal to 560 kilogram or pound. You know, these are the units of weight, and you see that after a time it's going to decay. Like you have something, anything, you know, we are just like talk about some material that a substance that after a time t is going to be like if it's a half life in radioactivity, the half life, the interval, the time that takes 1/2 of the original amount to decay. See, we have 560 and 280 kilogram. It will get to 280. Okay. Now we are going to write the formula. See, we have to find the general formula. Find the general formula for that too. You know, this is the general formula. Y is equal to initial amount is 560 e to the power of RT, And then when we find R, we find R first to find the general formula. This is RT. So what is going to be that we say that 280 is the formula here. 280 is going to be, the final amount is going to be 280, the initial amount is 560. E to the power of, see, here we got to say half-life. What is the half-life of a substance? Like we say, I don't know, we say like 4 hours. In 4 hours, 60 kilogram of that is going to decay until it gets to 280. So this one is going to be R times T. It's the half-life. This is the half-life. One half life. So we say like here at this example we say T is equal 4 hours. It means after 4 hours 56 kilogram is going to be 280 kilogram, the final amount. So we say 4R. In order to solve this, just let me give you an example. Like for example, you have, I give you an example here, e to the power of 4y is equal to 3. You are going to find the y. Okay? What you do, you get natural log of both sides, ln e to 4y is equal ln 3. See this one, ln 3. This one is going to be 4y, because ln of e to the power of 4y is going to be 4y. It means e to the power of 4y is going to be e to 4y. You know that. We talked about it earlier. And y is equal ln 3 divided by 4. This was just an example to see how it works. Okay, the same thing here. We say first 280 divided 560, divide both sides by 560 is going to be e to 4r. And this is 0.5 is equal to e to the is equal to e to the power of 4r. And we get the natural log of both sides is going to be ln 0.5 is equal ln e to the 4r. Okay? The same thing that the example we just solved, you know, the way to solve this one is the same. So this is going to be ln of 0.5 is equal to 4r. R is equal to be ln 0.5 divided by 4. So we find R. So here we say that ln 1.5 divided by 4 times t. This is the general formula. Now you find the general formula, and now at any time you can find like in 8 hours, for example. This is the general formula. Okay. Now we want to find that in 8 hours how much substance were decayed. And let's see. This is the general formula. So we find r. Now it's easy. This is times t. Okay. Now we say y is equal to y, the final amount. So y is going to 560 times e. See, you can find this one, but usually you have decimals there. But you know, it's more exact to write this like you say ln 1.5 CP 1.5 divided by 4. This is actually, it's going to be 0.10136 and continues. So this is the exact number. We don't want to put just rounded decimal places there. So we write ln 1.5 divided by 4 times the whole thing. You know, this is the whole thing is going to be like after 8 hours. 8 hours. See, you put 8 here. And that's the way to, you see, after 8, you will see what's going to be y. So, okay, let me explain again how we did it. We say like 280 is equal 560 e to the power of 4t. What we did, we get, this is going to be L 0.5, I'm sorry. This is going to be ln of 0.5 is equal for t. T is equal ln 0.5 divided by 4. It did that was 0.5. I wrote 1.5. I mean, you know, it's going to be 0.5. So after 8 hours, you see what is going to be the result of this. And see, is it 560 to the power of ln point ln 0.5 close the parentheses divided by 4 times 8, 140. After 8 hours, it's going to be 140. This is the half-life. So 450 kilogram. See what happened? At the 4 hours, you had 280 kilogram. Now, the more time it passes, the less amount of the final amount is going to be less than the initial amount. So the initial amount was 560. It's got 280 at 4 hours in half-life. So the half-life is the time to take that. What it means, it is the time interval that takes for 1/2 of the original amount to decay. Half of it decays, you know. But 8 hours, so at 8 hours it's going to be less than this. So we got it 140. So that's if you can put another number here, like after 10, You know, you said like after like after 12, for example, after 12 hours it is going to be 7. Every 4 hours is going to be less and less. At this one, y is equal 560 e to the power of ln 0.5 divided by 4 times 12. Another 4 hours, it's going to be 7 kilograms in every half a life. Like, how about if it's just like 10? So we just put, instead of t, we put 10. Then it's going to be 98. 98, almost rounded, you say 99. 99 kilogram. 99 kilogram means like after 12, see, after t was 12, see, if this one was 12, it is going to be 70. So it's 10, it's going to be between 10, between 8 hours is going to be 140, at 10 hours it's going to be 99, and at 12 hours it's going to be 70. So that's the way to do it. You know, we get the using natural log to solve this problem. So there are, you got to solve some problem yourself to see that, like if this one was 224, for example, you had initial material, the initial amount was 560, and then y is equal to 224. So the whole thing is going to be like this. 224 is equal to 560 e to the power of r times 4, or 4r. You know, it doesn't matter. R4 or 4r. They're all the same. This is multiplication. You can usually, you put the coefficient, the numerical coefficient here, just behind this variable. And now if this is like this, is 224 divided by 560 is equal to e to the power of 4r. And then, you know, you can go and solve this. This is going to be 0.4, and you know, you can do the rest yourself. So